Hey everybody, welcome back to HPC Tech Shorts, the engineering water cooler here in AWS. Now, last time we spoke with Olly Perks, we were talking about the AWS Graviton 2 and the Graviton 3, and all of the architecturally interesting things about that new CPU that's in preview right now. And we were talking about some of the stuff that made it really interesting to HPC customers and machine learning users. So this week, we've got Olly back. Hey, Olly.
Hey, right. We said we'd be back.
We said we'd be back, and we are.
Yep.
So this time, now we said we'd be back to come back and talk about the actual the developer environment, because
Right.
while parallel cluster, we've done a pretty big job with parallel cluster of making sure that somebody who's wanting to build an HPC cluster on AWS can just have an easy choice between an Arm64 version with Graviton or an x86 one with either AMD or Intel. All of that stuff remains the same. You get pretty much identical experience on the outside of the box, from a parallel cluster point of view. But it's once you get inside the cluster that things start to look different, depending on whether you're looking at an Arm64 universe or an x86 universe, and that sort of reflects our community, right?
Arm is a new architecture for a lot of people, and in the HPC space, new architectures don't come around often. The point of today is just to reassure people and to show that the work that we've been doing for the last, let's say, decade, getting HPC ready on Arm, means that anyone adopting this is going to get a really consistent user experience when they're porting their codes or uptaking their codes from an x86 environment. So that's what we're going to do today, is just talk through some of the differences, some of the familiarity points, and just make sure everyone's happy picking this up and isn't going to run scared that it's some mystical new architecture.
It's interesting. This is really the first time we've seen a new entrant into the HPC processor market where clouds existed to make stuff simple. Like, we'll talk about CI/CD later, but CI/CD and SPAC, you couple those two things together and suddenly you can automate the process of actually trying to get codes working and exploring the space of what works, what doesn't work, what's performant, what isn't performant. You can automate most of that.
Exactly.
To such a degree that a lot of the busy work of trying to get a new CPU up and running in the universe is much easier now. So,
and our net goal with all of this is just to get people able to use instances without even noticing they're on an Arm platform. It just shouldn't matter to them. Like, we've spent years trying to make this stuff boring because no one wants to have to worry about all of this when adopting it. So
that's exactly right.
I mean, first thing to mention is you've got two routes into using Graviton on AWS. You've got standalone instances, or you've got what you can access through parallel cluster. So the support, if you're just doing a standalone instance, right, you've got as many operating systems as you want. And this is just the AWS provided stuff. If you start looking on Marketplace, there are a few community supported operating systems if you want a Rocky or anything like that.
And you can, and amongst all of these options, you can choose whether you want community supported ones or commercially supported ones to pick your poison. And of course, you can choose which side of the Red Hat or SUSE fence you want to sit on. You can go Ubuntu or Debian, and of course, Amazon Linux is the one that we support ourselves.
Right.
All right.
And,
so that so
and
much.
then when we start talking about parallel cluster, we're working on a bit of a subset of this. So this is just Amazon Linux, and it's Ubuntu as well.
Anyway, so there's an important point to make there, because a lot of the machine learning users who are using parallel cluster to train their models and so forth are Ubuntu users, because Ubuntu is the thing in machine learning, right? That's the environment. So that's there. Plus, of course, Amazon Linux itself.
Right, exactly. So I'm not going to go into the kind of deep configurations of parallel cluster or anything like that, but I just wanted to provide it as an example. If you are spinning up parallel cluster on a Graviton 2, in this case, instance type, then you're already provided with a kind of bare bones HPC environment. So you've got an MPI already installed that will work. You've got all of the libraries to get your high performance networking through EFA working. That's the libfabric library. And it also ships with the ARM performance libraries. So you already get some optimized maths libraries that are tuned for Graviton. Pretty good starting point for people.
All right, now let's talk about where we go above and beyond that.
Right. So now you've got your instances. You want to get your code on there. You want to have a familiar experience developing using code, and so I figured IDEs are a good choice. I'm not even going to get into the Vim Emacs debate. I'm going to sit above that and say, well,
right, because we all know that VI is superior to Emacs, so we don't need to debate it. Yeah,
right. But we live in modern times, and you've got things like VS Code, which is getting massive adoption in the community, and it's got some of the remote connect features. So this is me on my Mac laptop, which is an M1 based laptop as well, connecting to a Ubuntu Graviton 2 instance. I've got the stream micro benchmark up on here, and yeah, it looks and behaves completely as normally. I'm able to run remote commands. I'm able to build, execute my code, all through an IDE on my desktop. The fact that it's backed by an ARM instance and the fact that that ARM instance is in the cloud, it just works.
Okay, so IDE is sorted.
You've got your code dev environment set up. You've checked out your Git repo, everything like that. So the next stage is when you get compiling with your codes. And I've already mentioned that, right, you're running on an ARM instance. You're not going to be getting the Intel compiler on here. So let's talk about what you can have on here. So the most kind of fundamental compiler you're going to get is GCC. It ships with the parallel cluster instances, so you're just going to have a base version in there. Now, I think it's important just to quickly have a mention of GCC. So there's a lot of stigma in the industry about using vendor compilers because the GCC performance isn't there. And I honestly do not see that anymore. That may have been true 10, 15 years ago, but if we're talking today, if we're talking latest versions of GCC and G-Fortran, it is really good. It's definitely worth checking out, and obviously making sure you're on a recent version of it, but you've got really good feature support, you've got really good optimization. It's a great starting point for people.
Yeah, look, Austin Cherian, who's also a frequent tech shorter, he's a compiler junkie from a ways back, and he said that in many of the other places where he's worked, where he's been working on compilers, it's been a bit of a race sometimes to stay ahead of GCC.
Right.
And that race has been getting harder and harder each year. So kudos to GCC. They're doing a good job. Now,
absolutely.
LLVM is kind of becoming the plumbing under everybody's compilers now, right?
Right. And we need to talk about that. And we've had a discussion about this, and it needs its own tech short, right?
Yeah.
There's so much about LLVM and the compiler ecosystem that sits around it that's really important to discuss. But I think first thing to mention is it is a first-class citizen on ARM, and it's used as a foundation for a lot of the other compilers that we're interested in.
And a lot of the other vendor compilers are feeding stuff back upstream to LLVM.
Absolutely.
So the ARM compiler is an LLVM derivative. NVIDIA's compiler is as well, and I mean that. So that means that there's features going back up into LLVM.
Right. There are a lot of interested parties in making sure that it is performing really well on ARM.
And then, of course, there's the ARM compiler, which good news recently.
Right. For those of you following the kind of community at the moment, it was announced this week that the latest version of the ARM compiler is now free to use. It's been a forum where we can put some of the latest, greatest optimizations, target the newest architectural features. And that's not to say that it's always going to be the best compiler for every workload on any ARM platform, but the compiler team in there make a lot of tuning and optimization work to really make it a solid go-to compiler. And one of the most important components of it for the HPC community is the fact that it's got a Fortran compiler. So this is ARM Clang, and it's based off LLVM's Clang, but it's really a solid Fortran compiler for those wanting to get up and running with HPC workloads on ARM.
And then, of course, NVIDIA's got their well, what do they call it? They call it the NVIDIA HPC SDK.
Right,
Is
exactly.
the correct name for it, but it's a compiler. It's a bunch of libraries and so forth.
We've been able to make use of these on Graviton instances, so it doesn't really matter if you either have or don't have a GPU attached to the node. You can use their standalone compilers, MVC and MV Fortran, and again, we're seeing some really good performance coming out of that, and they're doing a lot of work to optimize.
And of course, if I mean, the no-brainer is that if you're writing GPU code as well, if you had a GPU component of your workflow or your workload, I mean, it's kind of a no-brainer to use the NVIDIA compiler because you're likely to get the best performance straight away out of that. One assumes.
Right. And the whole GPU ecosystem, again, needs its own tech short to discuss that.
So actually, let's come back and actually do a deep dive on that, because it'd be really good to get some of the folks from NVIDIA and some of the folks from ARM to come and talk to us about that. But today we're going to take a pause there. We're going to come back in our next show, and we're going to talk about math libraries, CI/CD environments, and all of the things that come downstream for that, including SPAC and Easy Build as package managers for these really quite complex software environments. So come back, stay tuned, and come back for tech short number 2 in this series, or at least the second part of this tech short. In the meantime, if there's anybody out there that's got ideas that they want to see us deep dive into, things you want to see us discuss, please get in touch with us. Our DMs are open. We're here on Twitter. But in the meantime, we'll finish for today. Come back for part 2 in a couple of days' time and pick up the story from there.